Hey Math 2 students, how you doing? This is Mr. Flynn. I'm going to go through some notes with you today here, and then I'm going to go into doing solving for x. That's a key. We're going to solve for x. Sorry about that. Solve for x, all right, using quadratics. This actually is very interesting work. You'll see for those of you that have been factoring good, knowing your quadratics halfway decent, this is pretty interesting information. So let's see what we have here. When a function has x squared, what graph do we get? So when we see the graph, anytime we have that x squared in there, this is what's called a quadratic. All right, what is that graph? What do you think? Take a second to think about it. All right, I'll draw it. Could look like this, could look like this, but what's that called? It's called a parabola. Okay, so it could be an upside down U, it could be U here. We'll go over that a little bit more, but we've already studied the parabola and the quadratic, but we just need to kind of get a little better with it, and then look how we can solve for the x values, okay? The x-intercepts, remember there's special names for the x-intercepts. Can you remember them? There's I think 3 other names. I'll give you one. Roots. Can you think of the other 2? All right, how about zeros? And the last one is solutions. So they can be called one of 4 different answers. All right, they may say find the x-intercepts, find the roots, find the zeros, find the solutions. You're finding the same thing. You're finding the x-intercepts, okay? So with that said, I have a function here, and I have this graph. So in the function, x squared plus 3x minus 4, the graph is shown. So if you used your graphing calculator, your Calculate 84, if you were to put in this function and hit graph, you would get this graph, okay? And our first question is, what are the x-intercepts? Well, here's an x-intercept, and here's an x-intercept, okay? So we know that one of them, x is 1, y is 0, that's the point. And then the other one is x is -4, y is 0 again, okay? So those are the 2 x-intercepts, one here, one here. I just want to point those out a little bit more, okay? Now, here's the key. Think in your mind, put this in your head. So the y value for an x-intercept is always what? Look up here. What's the y value? What's the y value? It's going to be the same every single time. Anytime there's an x-intercept, the y value is always 0. Always. Okay? Without a doubt. All right? So that's a key clue for us. Okay? What I'm trying to say to you is, if we know the equation, if we know the function, anytime we set it to 0, we're going to get an x-intercept. But there's a special way to do that, okay? So if you think about it, and I'll erase these, and I'll use a different color here. You could have 2 x-intercepts, or 2 roots, or 2 zeros, or 2 solutions, right? You can have 2 solutions. But remember, you might have a parabola that looks like this. And in this case, it never crosses the x-axis, so there are no solutions. All right, that's going to happen sometimes. We're going to see that. That's a special case, no solutions. Then, if you recall, and I'll get rid of this stuff, we may have a parabola that comes and just barely touches. Let's get it up there a little higher. Barely touches. And just barely touches this. And it only crosses the x-axis once. And there's one solution, or one root. Right? Same thing. Or there's 1 0. Okay? So in a quadratic, you can have 2 solutions, 1 solution, or no solution. Oop. okay? So just keep that in mind. We're always going to have that opportunity. I'm going to give you a lot with the two solutions. You're going to see some with one solution, and we're really not going to do too many with no solution yet, but this is going to come as a special case. This we're going to see a little bit today of a special case, and I'll show you that as well, okay? So let's go. We're going to use factoring. So if we were to come down to this example here, and some of you might be going, I don't know where this is going, Mr. Flynn, I'm not quite sure. Just take this and factor it. What's the greatest common factor of b squared minus 3b? And that is a b. So if we take a b out of here and a b out of here, we're left with b squared divided by b is b, minus 3b divided by b is 3, and you're done. So this is if you were to just factor. I'm not asking you to do anything else. I'm not asking you to solve for b. I'm not asking you for anything. But because we have a b squared, all right, the b is considered our x value on a graph, okay? It would be our x value, wherever that is, okay? And whether it was here or whatever, we have to understand that the b in here is now the x. So I will try to keep x as much as possible, but you'll see what I'm talking about. So now what we're going to do is we're going to use the idea of this. When the y value is 0, we know the x-intercept, right? So down here, we don't know what the x-intercept is. But if we set it equal to 0, then we can find it. Remember, if this is the x, the solution is the y. So this is our y. Or it could be f of x equals f of x equals, and I'll do it even differently. I'll say f of b equals b squared minus 3b, where the function is the y value and those b's are really the x values, okay? So keep that in mind. If we set that y value or the function part equal to 0, now watch what happens. We're going to factor this the same way, where we get the b out, we're left with b minus 3. Now, I'm not going to show that because I just did that over here. All right, it's a binomial, but this equals 0. Here's the trick. This is a factor, and this is a factor. This times this equals 0. So one of them, or both of them, equals 0. So what we do is we take each factor. Now I'm going to use a different color. Here's a factor, and then here's a factor. So I have two factors. I take each factor, b, and I set it equal to 0. And I solve if there needs to be solving. That's done. I take the other one, b minus 3 equals 0, and I solve. These are my two solutions. Remember, solutions are roots, are zeros, are x-intercepts. So there, if I were to graph this, all right, I'm going to get a lot of this junk out of here. If I were to graph this, it would cross the x-axis at 0 and at 3. Those are the two answers, okay? Now, you might be saying to yourself, wow, I've never seen this before. That's okay. Watch this. Here's a factor, a trinomial you've done before, right? We know the last term is positive, so that means both of our factors, 4, 1, 4, 2, and 2, are the same sign. If they're both the same sign, they're both positive. Which one gives you a positive 5? Right there. So we get x squared plus 1. Oop, I'm sorry. Let's do it again. I get x plus 1, x plus 4. You just factored it, right? But what if it was equal to 0? And then when we factor it, and I'll get that x plus 1, x plus 4, that's what we did over here, and set it equal to 0. Now this times this equals 0. So that means this one or this one or both of them are equal to 0. So just take them, x plus 1 equals 0, and solve. And take the x plus 4 equals 0. Oop. And solve. And those are your two roots. Those are your two solutions. Those are your two x intercepts. Okay? And what would the coordinates be? Easy. -1, 0. -4, 0. Because remember, at the x-intercept, y is always equal to 0. And we talked about that up here. Okay? So what's the key here? You have to know how to factor. That's key to this. Then you just take each of those factors and set equal to 0. Now, notice each time I did those two examples, and I'll use a different color to point it out. When I did this one and I did this one, it was already equal to 0. All right? That's the first step. That's all we're going to deal with today. We're going to deal with factoring that equals 0 so we can do. In the future, what we're going to do is when we factor and it doesn't equal 0, what do? It's an extra step, but we still do the same thing in the end. If we factor, set each thing equal to 0. Okay? So let's do a little practice again. Here we have our last one. The last term is negative, so we have a 1 and a 3. We know that it's negative, meaning both these signs will have different signs, and the larger one will be negative. So this becomes x plus 1, x minus 3, right? So that, again, just practicing factoring, we should be getting that. Do the same thing, same exact equation, but notice it's equal to 0. How many solutions does it have? Well, we know that we have x minus 3, x plus 1 equals 0. Remember, that's what we have from over here. And then take this factor equals 0. I'm going to add 3 to both sides to solve. And then take the next one. X plus 1 equals 0. And I have two solutions, or two roots, and there they are. Okay? Now, let's see here. What I'm going to do is I'm actually going to go to your worksheet that I have for you. Where am I doing it? Oh, here we go. Beautiful. Notice the top part is done for you, meaning we don't have to factor. We already have it factored, and it's already equal to 0. Those are the two keys. Make sure that it is factored. Make sure it's equal to 0, right? We'll talk about that in the future. Then you take each factor. There's a factor, and there's a factor. And set each one equal to 0. B equals 0, solve. That one's done. B plus 5 equals 0. Subtract 5. And we get B equals -5. So my two answers are B equals -5 and 0. Another way to show your answers, okay? Not too hard. But all you do, we'll go to number 3. It's already factored. Here's a factor. X minus 6 equals 0. Solve. X equals 6. N plus 4 equals 0. N equals -4. So N equals, and now look at the order I put them in, -4 and 6. There's your answer, okay? Now, look at number 5, special case. When it's squared, it means x plus 4 times x plus 4, and that equals 0. So set that factor equal to 0, x equals negative 4, and then set the other one, x plus 4 equals 0, x equals negative 4. Notice they're the same. This one has one solution, negative 4. Okay, so this one is that special case that I talked about. Remember, when you see a graph of it, wherever it is, it's going to cross at negative 4 or whatever. So it's either going to be down this way or the other way. Okay, it's either going to be a U or upside down U, but it only has one solution. If that was 1, 2, 3, 4, x equals negative 4. Okay. Now, I'm going to show you 7 and 8 because I don't want you to think that you just take whatever's inside and make it its opposite. You need to solve, and that's why it became the opposite. Look at number 7. We have this one. We have 5v plus 7 equals 0. So you subtract 7. We get 5v equals negative 7. Divide by 5. And we get v equals negative 7/5. And then we take the second one. 5v plus 2 equals 0. Subtract 2. Notice the math is pretty easy, but you just have to be careful. V equals negative 2/5. So notice we can get fractional answers. Not a big deal. Leave them fractions. Leave them fractions, okay? So I've done what, 1, 2, 3. I've done 4. You can do the other 4 on this side. On this side now, they want you to factor. So on number 9, what's the greatest common factor? X. If we divide by x, we're left with x. If we divide by x, we're left with plus 4. So we have this factor. We're done. We have this factor. Subtract. We have our two answers, x equals 0 and 4. Well, actually, that's a negative 4. Going too quick, okay? Not too hard, all right? I'm going to do one more. Number 11. All right, it's a trinomial. The last term is negative. So we have 32. The factors are 1 and 32, 2 and 16, 4 and 8. And 5, 6, I think that's it. So if the last term is negative, that means the signs will be different, and then the sign of the larger one will be negative. Which to add to that negative 4? Right there. So we get x plus 4, x minus 8 equals 0. Now, take our first factor, equals 0. Notice the math is not hard after you factor. Take the second one. And so I have x equals negative 4 and 8. And if you take any one of these numbers and you plug it back in, it'll get you 0. If you take 8x squared, like 8 squared here, minus 4 times 8, minus 32, you'll get 0. Okay? It just works that way. All right? So, I think you can factor. For those that are struggling with the factoring, you need to reach out to me. If this is the 3rd period class, you need to reach out to me or Mr. Philas. If it's the 8-9 period class, you need to reach out to me. You need to reach out to Mr. Owens, or you need to reach out to Miss Mango, okay? Factoring, solving for the variable. You'll always know it's solving because it's going to equal something, all right? It's going to equal something. Right now, it's always going to equal 0. That's what we're going to practice today. And so we're just factoring one side and then taking each factor and setting each one equal to 0 and solve and get our two answers, or sometimes there's only one answer, okay? We're not going to have any with no solution, so don't write no solution.